For question 1, part A, says describe the correlation. Since we are given the regression line and the gradient is positive, then this means that we've got positive correlation. Note that the question says describe the correlation and not interpret the correlation, so just positive correlation will give you the mark. For part B, it says give an interpretation for the gradient of the regression line. The interpretation is for every extra point, the pay increases by £4.50p or something equivalent. It must be in context and it should refer to the 4.5. In part C, it says explain why this model might not be appropriate for all jobs in the company. Note that for some values of x, y comes out to be negative. Let's try and find those. So 4.5x minus 47 is less than 0. X is less than 47 over 4.5. Comes out to be 10.4 recurring. So my comment will be for less than 10.4 points, the pay will be negative. In question 2, I'll start by drawing a tree diagram. The first split will be 3 branches for companies A, B, and C. The probabilities on each branch will be 0.1, 0.3, and the remaining, which is 0.6. And then each branch will split into another 2, one for faulty and another one for not faulty. Now for the first faulty one, I'm going to have 0.09, so 0.91 for the not faulty. From B, the faulty one is 0.03, so not faulty is 1 minus this one, 0.97. And for the third one, since I don't know it, I'm going to put a P and 1 minus P below. Now I'm given that the probability of being faulty is 6%. So I'm going to calculate the 3 products, these 3 products, and I'm going to add them up and I'm going to equate them to 0.06. So the first one is 0.009. The second one is again 0.009, and the third one is 0.6p. And if I add this up, I will get 0.009 plus the same thing plus 0.6p, and this must equal to 6%. So 0.6p is equal to 0.042. P comes out to be 0.07 or 7%. For part B, there are 2 methods to show that they are not independent. Now, method 1 is more common. Probability B is equal to 0.3. Probability F is equal to 0.06. These are given. If I multiply these 2 together, I will get 0.018. Probability B intersection F is equal to 0.009. I know this from my tree diagram. So probability B intersection F is not equal to probability B times probability F. Now if you're using method 2, this is a bit simpler. Probability F is equal to 0.06, but probability F given B is equal to 0.03. This is the probability from the faulty branch following B. and just note that these two are not equal. Now, whether you've gone with method 1 or method 2, make sure you write a small conclusion, so not independent. Now, I will start question 3 by defining what my x variable will be, or any other letter you want. In my case, it is the number of games he wins. And given this information, x follows binomial with parameters 15 and 1/3. Note the first letter is the number of trials, the second one is the probability of success. So in part I need the probability x equals to 2, and this comes out to be 0.0599. Note that I have used binomial PD on my calculator. For the second part, I need the probability x is bigger than 5. Note this is like saying from 6 all the way to 15, which is the maximum. So this is 1 minus probability x is less than or equal to 5. Less than or equal to 5 is like taking 0 to 5. So this is 1 minus 0.61837, which comes out to be 0.382 to 3 significant figures. Note that I have used the binomial C&D option on my calculator. In part B, I need to set up two hypotheses. The null hypothesis is always equal to something, in this case 1/3. The alternative one, well, for this one we have to see at the wording of the question. So there's a claim he will win more than 1/3. So my alternative hypothesis will be P bigger than 1/3. Again, I'll need to define my variable. Since x is the same, I'm not going to write it again, it's the number of games he wins, but this time x follows binomial 32 and 1/3. N is my 32, P is the 1/3, and I will need to calculate probability x is bigger or equal to 16. That's my observation. Now this is like saying from 16 to the maximum, which is 32. So I'll need to rearrange this one to be compatible with my calculator. Now less than or equal to 15, it's like saying from 0 to 15. So that's 1 minus 0.9623, which is equal to 0.0377, and this is less than my level of significance. So this means that I have sufficient evidence to reject H0, so his claim is supported. For question 4, I'll need to calculate some sums, and I will use my calculator to do so. Also note that the 13 not applicable will be ignored in my calculations. So using my calculator, sigma fx comes out to be 184. Sigma fx squared is 2062, and sigma f is equal to 18. So in part A, the mean is equal to 184/18, which is 10.2 to 3 significant figures. In part B, I've got standard deviation equals to the square root 2062 over 18 minus my mean squared. I'm using full accuracy, comes out to be 3.17. And in part C says using your knowledge of the large data set suggest giving a reason which month has a mean of 11.57. Note this is the highest mean, so wind speeds of 11.57 should occur in autumn since the months in the large data set go from May to October. The most probable answer will be October, although September is accepted, and the reason would be since it is windier in the autumn. Then in part D, I need to first state the meaning of the star, and then secondly and most importantly, I need to find which of the months in table 2 is most likely to be summarized by the box plots marked Y. So for the first part of my answer, the stars represent outliers. And then for the second part, let's investigate these box plots. Now let's find the median and the IQR for each. Now the median for the first one is 9, for the other two is 7, 8 for the fourth one, 13 for the last one, and then the IQR is 4 for the first one, and then for the rest IQR is the same, it is equal to 5. Now note that month E has a very high mean and standard deviation. So E is probably the last one. Also note that A has a low mean and standard deviation. So A is probably the second one. Now Y has the smallest median and the largest IQR and also an outlier. So we expect a low mean and a high standard deviation. So excluding A and E from the other 3 months, we expect Y to be month B, although C and D are also accepted in the mark scheme. So let's write all this down. For question 5, I'll start by observing that when R equals 1, I've got probability X equals to 1 is equal to probability X equals 3. And when R is 2, probability X equals 2 is equal to probability X equals to 4. I'll continue by constructing the probability distribution of X. Now probability X equals 2 and probability X equals 4 are the same, and these are given by the question as 0.35. Now the other two probabilities are again equal based on this statement, and I know that all the probabilities should add up to 1, so I'm going to calculate 1 minus 0.35 plus 0.35 and then divide by 2. This will give me 0.15, and this is equal to probability of X 1 and 3. In part B, I will define my variable a or any other letter. I'm avoiding to use x because I've used this above. And this is equal to the number of spins that land on 4. And a follows binomial 60, 0.35. The first letter is n, the second one is p. I need probability a is bigger than half of 60, which is 30. Note, bigger than 30 is like saying 31 all the way to 60. And this is equivalent to 1 minus probability. And I need here to exclude 0 to 30. So I'm going to write a is less than or equal to 30. And I'm going to use binomial CIND to do this. So this is equal to 1 minus 0.99411, which is equal to 0.00589. I will solve part C using two methods. So for method 1, I'll start with probability y minus x less than or equal to 4. I will substitute 12 over x minus x is less than or equal to 4. This will give me 12 minus x squared less than or equal to 4x. Now, usually when I multiply by something unknown and I have an inequality, I don't know whether I have to reverse the inequality sign or not. In this case, I don't need to worry because x is between 1 and 4, so x is positive. So no change in the inequality sign. If I rearrange, I get probability of x squared plus 4x minus 12 is greater than or equal to 0. Now I can factorize this. It's x plus 6, x minus 2. I'm going to handle this as any quadratic inequality. I have two critical values, minus 6 and 2. I need the values of x for which this quadratic is positive. So I've got x less than or equal to minus 6 or x bigger or equal than 2. Now since x is between 1 and 4, I'm going to reject the minus 6. So this probability becomes now x bigger or equal to 2. And from my table, this is 0.35 plus 0.15 plus 0.35, which is equal to 0.85. Now for method 2, I will recreate the probability distribution table I had above. On this table, I will add another row for y, which is 12 over x. So I get 12, 6, 4, and 3. And then I will add another row for y minus x. I've got 11, 4, 1, and minus 1. And I need the values of y minus x being less than or equal to 4. So these three are the values that I want with probabilities 0.35, 0.15, and 0.35. So probability y minus x less than or equal to 4 is equal to 0.35 plus 0.15 plus 0.35, which is equal to 0.85 as before.